So, ladies and gentlemen, my name is Mark Marlene, and today, just like always, we would be streaming our what they call progress. Right. So, we would be designing once again our hardware. Right. So, we need to get some applications open on first of all Android IDE or something. Right. Arduino IDE, not Android. Kind of forgot that wrong. We won't be designing software again. We would be designing hardware, and I do got a multimeter. If you can look, let me just show it to you guys. So yeah, it's a unnecessarily expensive thing, but what it pretty much does, it tells you like the voltage of like if there's current passing through something or something is even receiving a current or not. I mean, I'm gonna use ChatGPT to learn how to actually solve it, and I think I need a screwdriver to kind of like run it or something, because I think it doesn't like how do I run it or something. Like I don't even know how does it get on or something. I do got multiple wires and some cells too from the company or something. I guess you have to open up the backlit or something, and then you have to get a. I need to go downstairs for that, and I'm kind of tired to do that, But I guess we just have to um push it through or something. Yeah, we do have to go downstairs, I guess. So yeah, once that is done, I mean, I need to connect it with my first of all, I need to connect my ESP32 to hub or something like that, right? And I need to check. Okay. We would also be getting like what they call like USB analyzer or something. USB analyzer is a good thing, trust me. So what it pretty much does, it allows you to tell if any chip is responding or not. So it just pretty much tells you if the chip is dead or alive or something like that. All right. So and okay, now I'm streaming a lot of things and it still gets yeah. So we got that, and we actually need to open up another cybercoding. We need to just close this shit. Right. And we need to open this bad boy up here on the left side of the screen. Right. And then we've got reflections, which I don't really give a shit about. A new tab. We had a what they call the design. Oh, not the design. Okay, where was it though? I did remember I wrote the entire design for the structure or the software or something. Like, yeah, let me just, it was in my daily notes. Yeah, it was on here. So hardware to control and the temperature is, first of all, we need hardware. After that, we'll kind of like integrate hardware with the software. All right, so yeah, after this our IoT or AOT, I think they call it IoT or something like that, which is pretty much, so then after then we will be able to kind of like simultaneously control temperature of our room without having to do anything. So like once the hardware is done, I would be able to send command to my AC through the laptop, and then so my laptop would be able to control using software my AC. So that means like in pretty much simple terms, it's like you would be able to control the room temperature, right, of your room through AC or fan, because I have smart AC and smart fan, and both will be simultaneously connected to the hardware, and the hardware is connected to the laptop, and the laptop has a software that signals to the hardware, which sends signals to the AC and the fan. So so it pretty much controls your room temperature. And what the software would do is like it will pretty much gather information about my sleep schedule, about the environment, about like where I live or something. So it will get the environmental data, and on the basis of that, it will get like because we have hardware too, and it'll use hardware to get the temperature of the room and stuff like that, and then it would be able to pretty much control the entire room temperature without me ever having to think anything about it or something. And then I can get that software to my phone and connect the hardware to my phone rather than to my laptop, because I cannot have laptop running the entire day, right? I mean, so once it's connected to the phone, I pretty much have to just put my phone in the room and the autonomous thing would just function. Unlike the laptop, because I don't have to like open up my laptop or anything. Right, so I do need to ask ChatGPT how to use multimeter or they call it multimeter, right? Like this bad boy here. So this is pretty much like I bought it because I didn't know like at the start, but how useful this thing is, right? But I do need to learn how to use it. So let's just see what ChatGPT says. Okay, so how do you use a multimeter? Like I bought a multimeter, and it's not really expensive one. It's kind of cheap one. Right, but yeah, I do think it's get the job done, and I would send you the screen, like a photo of it, of the front side and the back side, right? And what I want you to do is like tell me to, yeah, how does it function or something. We got some stats. Nah, we got some docs chat. Yeah, bro, that was because of RAM. My RAM is successfully upgraded, I got that done in the morning. Yesterday too, it didn't got updated. So today morning, yeah, I went to the stop as early. Yeah, they told me like they're free at 10:30. That's why I'm kind of bro, man, a little late. So yeah. So now the RAM is done. All right. So yeah, we would not be late anymore. Hopefully. Yeah. And how do I take a photo of this? I mean, I don't know. I can only take my photo of this through using phone. And I do think I should be creating like a podcast, like what they say, um, like very early or something. I don't know. Mm. Ah, shit. Yeah, bro. Once we got the hardware, then man, that would be like hardware is the biggest obstacle, Nicola. Like yeah, OG Pro or whatever. Like once we got the hardware, it's so easy to get the software done because like yeah, I've read a lot about software too, so that's kind of also helps. And like yeah, I've read system thinking or something. So software wouldn't be like software is a problem too. I'm not gonna lie, especially when you are scaling it. But then again, it's not as hard as hardware because like with the hardware, I'm pretty much new. Never knew anything. Never done anything with the hardware. Like everything is new. Like started from scratch or something. But like yeah, with I don't think so. Such a big problem would appear in the software too. So that is like an advantage for me, I suppose. Yeah, which kind of like fixes the thing up, I suppose. Where is it though? Yeah, yeah. What? I have such garbage communication here. Let's just remove that. Yeah, let me just add some photos. Done. Okay, so how do you use a multimeter? Like I bought a multimeter and it's not really expensive and it's kind of cheap one, right? But yeah, I don't think it's, but I do think it gets the job done and I would send you the photo of it, like the front side and the back side of it, right? And tell me like how does it function or something and how do you effectively use it? Yeah, let's just hope this works. This works, right? So yeah. Where's my phone stand? Here. The probes, okay. Probably reason big enough multi looking at your photo. It's Themis T8 True RMS multimeter. It's battery sensor receptors and basically it's more than sufficient. Yeah, I do know it's more than sufficient, or I wouldn't even have bought a ChatGPT. My friend. Oh yeah, the wallpaper. I changed it. Oh, I just went on Pinterest and yeah, something like that. I just like the flower or something. All right. Yeah. Mm, yeah. So it's like okay. Yeah, it's kind of okay. But there's yeah like the probes. Black probe, calm. Okay. Now it's time to understand this shit. We have calm always stays here. Use 95% only when measuring large current. Red probe. Okay. 10 ohm. Okay, 10A. 10A. You would be only using 10A if you are a large current. So I would be using like a. Yeah, so I would be just using like, okay, that. Black and red for almost thing you'll do SPST. The probes will be black, calm, and VA. Leave the A signal unless you're intentionally measuring high current. The dial. Your dial has several measurement nodes. Oh, I said Pinterest, right? Did you not hear? I get the wallpaper on Pinterest. Your dial has several measurements nodes. I do know that. DC voltage. This is you'll use the most. Okay, DC voltage. What is that? And where's even DC voltage on the? Okay. Whatever. Huh? Where's the fuck DC voltage is? They call it, okay. Oh, so the entire thing is DC voltage. Okay, the entire thing is DC voltage. There's nothing that mentions that. Mostly is 2V, 2V, okay. 2V, that line, okay. I'll use 2V and I'll use 20V, 200V and 600V. Okay. Use this for the battery power. For example, ESP pin. Okay, USB charger around 5V. Set the dial to 20V. Ah, AC voltage, left side. Yeah, there's DC current and there's AC current, right? Mine is around 200V AC. No actual wall socket until you're comfortable. Measure resistance range included now 2k ohm, 200 ohm, 2 million, 20 million. Okay, there's million. Okay, that's oh yeah. So there's first of all DC current, AC current, and that. So yeah. I mean, let's just see what Nikon AG Pro wrote. Right, let me just open a bit. Oh no. Like you can if you download it on the phone and send that from your phone to your laptop. That's pretty much it. So I scrolled it through the, yeah, you cannot download it. You literally cannot. If you download it, you'll get a 30 or 60 KB file or something. But what I did is like I downloaded it, uploaded it to Canva, and then like yeah, installed it from the Canva to my continuity node, speaker diode symbol. Second most useful mode. Okay, this is flashlight mode. Okay. No, the continuity mode, speaker and diode symbol. This is probably the meter beeps. Use it. Solder joints when two pins are connected. You'll use this constantly while debugging diode mode. Ah, COM. Okay. Current A measure current flowing towards circuit. Range is included now. Okay, that's just yeah. Current is never measured by touching the probes. Okay. And continuity. Okay. Hold. Use. Measuring the ESP through TV3. EDC. Read the display. Approximately this. Black probe, red probe. Okay, we won't be using 10A, right? So so like you go the back to back or What the fuck? What does this do? Again? What's wrong with the multimeters? I don't know, man. What's wrong? What's wrong with my multimeters? Let me just go to like again, let's just say let me just go to YouTube. Yeah, there it is. And let me just search multimeter. Uh Yeah, first of all, you have to desync with the society if you are trying to wake up early, right? So yeah, you get more and more lonely over time if you try to wake up early. There was a YouTube video there, yeah. Okay. Okay, Obsidian Vault deactivated. Cybercoding file not found. Okay, but that's because maybe drive folder went offline for a couple of minutes. Right. Maybe I should like, yeah. So, okay. Right. Hey, there are some new viewers, I suppose. Do you guys want to know like what we are actually doing here? If you guys want to understand, you can type in chat, right? Like, yeah, if you have like want to know about anything. Okay, there was something. You are what a Are you a code cell or vibe tune? Okay, what that means? I don't know. New to music gang. You are code code CL. I don't know what that means. Well, the problem is that when I'm focusing, I do not read the chats, right? So I guess you have to be patient for at least 5 minutes or something, right? I guess that's kind of common in every stream. People don't immediately read your chats, right? I mean, I guess that's all right. But how do I insert the? How do you insert the? Okay. How do you insert the pin in multimeter? Like, I don't know what that means, but I do know what that means.
A multimeter at first could seem intimidating, but by the end of this video, you'll know everything you need to know to fully use your multimeter, from what every sign means to what they do. We'll also look at some examples.
I don't know the name of that flower, bro. How would I know that?
Could be used. Finally, we'll take a quick look at different multimeters and compare their features to decide which is best for you. Now, every multimeter has different features, but
Actually, you know what? Oh, Oh, so you can even do that. I didn't knew that. Okay. Oh, I can even do that, huh? That's great now. Hmm. Finally, some focused studying without some random basic questions that I have to answer.
There are standard measurements and symbols across most units. So let's take a look at that first. First off, we have voltage represented by a capital V. This will allow you to measure voltage of power lines and devices. The power in
How do you add though? How do you add? Okay.
use
Yeah.
our multimeter and test this battery. At the top of the battery, we have labels which tells us which terminal is which. After setting our multimeter to voltage, direct current, we then place
Wait, what? His connected. Mine didn't. Okay, do you need to apply a lot of pressure? Mm-hmm. No, it's not working, even if I do apply a lot of pressure. In fact, I'm scared that it may broke or something. What? Maybe I think I need to supply it with battery or something, only then it's gonna get inside or something like that. Maybe I need to do that first. Yeah, I need to get a screw, I suppose. Yeah. I'll be back in a minute or something. I mean, I don't know about like others or something, like, but they would come and stream again and again. And what they'll do is like they'll ask some random bullshit question about wallpaper, about my age, about my religion, about they never ask that there's a single question related to, you know. So I'm kind of cruel that I kind of like hided the first person who ever became my constant viewer. But man, like if you like, they just wants to like bug me or something. They'll come every 5-10 minutes or something, man. Damn, it's not like here I am studying and you asking random bullshit question that has no meaning or something. If only they ask even a single good question, I mean, I wouldn't mind, you know? Okay, this entire thing comes out. Right? I think you just can't mess up with the, like, yeah. But yeah, I mean, yeah, I was really hopeful. Each time someone would come, I was like, okay, maybe it's finally someone there who understands what I'm building or doing here. Right, someone who, oh fuck. Someone to even know about what they call the basics, you know, of like a hardware or something, or not basics, but if they are slightly interested in what I'm doing, like in what I am doing, rather than not wasting my time unnecessarily asking me a question that doesn't matter, like, you know. about my graphic card. Like, yeah, man, it wasn't useful at all. What they were doing, again and again, like literally again and again. Okay, we have our baby active. I think we do need to kind of like get this back. I'm kind of scared. That's why. Yeah. So, I think yeah. You guys do not wanna see my face anymore, right? Don't worry, guys. I'll show you everything. So, like, that's how it's pretty much going here, right? Like, yeah. I cannot zoom in, sadly, but yeah, you get the gist, like what I'm doing, right? So, and as for this bad boy, it can go like here or something. So, okay. So let me just tighten this bad boy up, slightly tight. Yep, here we go. It should go there. Right, so we've got our multimeter check. The beep is on. Let me just give my headphones, baby. Let me just give my phone a fire. But yeah, I may end up taking another screenshot. Can I get it in? Again, I cannot get it in. So I just need to ask ChatGPT again. Right, so we need to add like a photos. But first of all, we need to take photos. We'll take this. We'll take a camera or something. We'll add these two and only these two so that there's only information about these two. We'll edit a little bit for the betterment for our ChatGPT. ChatGPT is getting smarter and smarter over time. By the end of the next year, anyone who doesn't use AI would be stupid bitch. Not gonna lie. Right, so we've got this picture, right, guys? So now we just need to take like okay, they actually have that picture. We have photo, we can. Okay, so ChatGPT, like how does I insert this into like into my the com and v ma like section? Like I'm trying to insert them, but like they're too big for the area. Like they're just not getting in. Do you need to like apply extreme pressure or something? Ah. Protective plastic or something? Ah, okay, yeah. Okay, yeah, there is a protective plastic. Didn't knew, man. Didn't fucking knew. So now it should get in. I was doing a big mistake. Now I'm kind of scared. How do I off this? First of all, let me just off it. I'm kind of scared. Yeah, the plastic. Nah, that's taken off. Like I don't know if this plastic is useful or not. I really don't think so. It's useful to keep it here, but let's just a problem solve. Extreme force. Okay. They don't require extreme force or something. Right? Yeah, so now I should be able to check. Right, so let me just get to ChatGPT again. Let me just reload. Let me just fucking, move that. Let me just fucking remove this or something. Let me just get this done, get this done, get this done. Right. Yeah. Now I just need to ask the ChatGPT, okay, how do I check now? Man, I'm kind of excited finally a little bit. Okay, so ChatGPT, now I've got them connected actually, to my multimeter. So now I'm setting like the DC voltage to 20 to check my ESP32. Like how do I check it now? Like ESP32 has a couple of pins too. I mean, So finally, guys, we can debug a lot of stuff. Like, okay, first of all, let's just see what ChatGPT has to say. First of all, there's so much unnecessary thing. Can I put my keyboard aside for a sec and just focus on the shit? And I can use that keyboard for more space. Yeah, Yeah, actually, I can do that, right? And I do not need you here for now. Like, yeah, all the things should go. Like, I should get another table, and that will come here. Now you'll say, Varric, why do you even need another table? And I'll say, my friends, that's because I'm doing hardware, and there's not much enough space on my table, so I need multiple tables. That's it. Okay, set the multimeter, and first I'll set the temperature, bitches. I don't know why, but finally project is moving somewhere because now we can debug whole shit ton of things. First of all, let this bitch disconnect it. Oh yeah, I do always needed to know if the pins are even supplying electricity or not. Yeah, finally it's time to test that hypothesis. Finally it's time to test this fucking bullshit hypothesis. Right, so first of all, we'll get them to 3v3 and GND or something. So what we'll do is like okay, like what does ChatGPT says? First of all, I need to look through that. So it's like power the ESP32. Okay, but let's put aside the breadboard for now. Like this bad boy doesn't need attention. We've put in aside the breadboard, which is connected to our BME32, but yeah. Now what I need to do, black cable is okay, first of all, I need to connect my ESP32 with this little bad boy here. Let's hope like they are connected or something. Don't tell me this micro USB is not the size of a micro USB. That would be hilarious. Okay. Yeah, this micro USB is definitely the size of micro USB. Of course, man. What was I expecting? Right, so yeah, ESP32 is connected now. Looks like I'm a fucking Iron Man. Black Pro COM, red Pro VAM. Right. Right. Dial 20 DC. DC section is straight over the dash line, right? Usually power lighted. Final GVD pins have several in 3v10. All GND pins are electrically connected. There's the probe, like probe G and D, like pins or something. So it's like a. So black should go ahead and red should go ahead. Don't press hard. Just try to make the contact expression metal pin. Written to 25. Exactly what you want. 3. Okay. A healthy display, right? So here goes our like trial number 1. Here goes nothing. So we would be using our wires, and I just want to know if these fucking bullshit wire that I've bought, like I need my black to go to GND or something. Okay, so where is the GND section? So GND goes to black, and 3v3. Okay, black goes to black. I can just say that, right? So shall I set this to 20? We have set this to 20, guys, ladies and gentlemen, and now I just need to connect these 2 wires, right? Let's just hope it works. It shows nothing. Okay, let's hope. It is literally not showing me any activity. Are you fucking bullshitting me? So black was supposed to connect to GND or something? Okay. Let me put these wires aside, these bullshit wires. Don't tell me all the jumper wires I bought are like bullshit, like, are like that. Let me just, so GND is supposed to be black, so we're gonna get like a, what was what actually? It says GND is supposed to go with black, okay, and okay, then I should actually change the way I'm holding them or something, right? And read the display, a healthy display, try 5e pin, we keep. My ESP32 hub is not powering electricity for some reason. Ah, the red wasn't connected. Ah, they weren't connected tightly. Okay, I'm sorry. They weren't connected tightly. I made a big mistake. So they weren't. Okay. Yeah. Oh my gosh, it's real time. Okay, damn, the bug finally worked, so that's working. Yeah. And we just need to get our two bad boy here to get plugged to this bad boy. Alright, this one bad boy plug, this another bad boy plug, let's just plug that another bad boy. Alright. And let's see if our jumper wire works or not. So now I can finally know if these wires are damn working or not. But yeah, if multimeter starts to hallucinate or go wrong, then that would be like a big problem. But I think I need GND to go with black. Yeah, GND with black. So black is here, red is here. Right, so yeah, so I just need to like black here and this here. So let's just hope that this works too. Ah, so there is some voltage there too. Okay. Now what we need to do, like, damn. First, now we know like our ESP32 is like working beautifully well. Right, so now what we need to do is let's just upload our serial monitor or something, right? Yeah. First of all, to our ESP32, right? And okay, now I need to like diagnose if the display shows it's a perfect. The probes are reversed, swap them. Okay. I need to press EN one time for it to bootstrap itself. BME280 not found. Okay. I think now, okay, first of all, I think I would still not be able to connect what they say, like my where is my BME32? Hey, what the hell? Okay, yeah, here is my BME or something. Now what I want to know is like if it powers the rails or something of my, yeah. Now we need to know if the breadboard is working or not. Like first of all, we know ESP32 and the wires are working perfectly well. We just need to know this breadboard passes the electricity or not or something specific to that. That's the only thing we need to know. Right. So in order for us to know that, all we need to do is like okay, now that's gonna be pain in the ass, but you get the gist. Right, so we need to get this here. We need to get this here, right? So, yeah, we need to get this shit here. And we need to get this shit here, right? And after, like, finally, once I got, like, tomorrow, I would be getting what they call, like, what they call it? Again, what they call it? Yeah, the USB analyzer. So now I can directly test if something is working or not. If something is, so if I do not know still yet, and there's a hard chance I still may not know, like, what is actually causing my sensors to go like they're going in a way. Where is my two wires that were supposed to be just right here? Did I just throw them anywhere? Did they fall off the, what happened to them? What happened to them? I don't know. Maybe they fall off. Maybe. Where are those things actually? Huh? Oh, here. They were like submerged in the background or something. Well, that's kind of alright, I suppose. Yeah, now we need to get them here. But before we get them here, I need to know by taking these 4 bitches out, are these 4 bitches taking the signal that I want them to take or something, right? So, yeah, so these 4 bitches, and this would be connected later. We need to know that if these 4 bitches even gets the signal through the breadboard or not. First of all, D21 and D22, that's where I needed to connect these things, right? So, D21 and per se D22, right? Let me just try to check them too. They in themselves are not. It's not showing any readings though, but I bet. Okay, it single-handedly doesn't show any reading. You have to connect both of them, right? So let's just say like. Yeah, it's minus something, right? It's minus something, so that means you just need to switch them and it should be in plus, right? So it's like something like this. Well, I don't know, but I do know that it is sending current, so I don't really give a shit for the rest. Now we need to carefully plug everything, so this should go here. That should go here. right? They should go here. This should go here. We would require a pref board in the future though. So now we just need to check this, especially the initial two ones. It's like, okay, what electricity are we getting? Is it our ESP32 passing the electricity where it needs to be passed down or something? Okay. I think the black, okay, we should be getting some values, right? So $3.35. Okay, so this is also sending electricity. Ah man, that means breadboard was never at the fault, baby. Our breadboard was never at the fault. Now I don't remember what connects to what, but I do need to check if this thing is getting electricity and if this is sending electricity to our BME 280 sensor or something, or if our BME 280 sensor is kind of like dead or something. Okay, I think I won't be able to disconnect them because they're so thoroughly connected or something. I shouldn't even try to disconnect them. Maybe we need to get another BME 280 or something. Right, so now we just need to connect this and this here. Okay, I forgot literally what connect to what. So we have to go to like a BME new chat. And we have to search the ME28 or something like that. Oh, sorry, not that. We need to search bitches. Okay, fuck. I said search. We need to search. E28. Branch BME. You can directly ask the sensor, read the temperature. BME is connected. Or I should like have entirely different things, which is like how about I go with rephrasing, so I go D3v3 G and D 3v, okay, 3v3. This is not. Yeah, here it is, right? Yeah, it actually opens up like an Obsidian notes or something. Yeah, here it is. 3v3 goes to win. So win, where's the win? The win is like a purple. And then after that we have like a GND goes to GND. So GND goes to GND. So we need to connect our win to the, okay. This is our most probably the win. This goes to purple. Alright guys. The purple goes to, then our GND goes to GND, which is, okay, yellow. We could directly actually connect it with male to male or female to male to female to female jumper wires, but we did that because we know in Statista, there were D21 goes to SDA, so we have like D21 is brown. Brown gets connected to what? SDA, which is like brown gets D21 gets to connect. Brown gets connected to what they call dark blue, right? So yeah. So this is also connected, and this is also connected. All right. Now we need to know if there is some happening. Okay. Now I need to just ChatGPT on. Okay, where's? Yeah, everything is working perfectly fine now. So like, yeah, we were able to check ESP32. I was able to connect ESP32 to my breadboard and then check if the wire was like powering using the breadboard. And yeah, but now I want to check BME28. How do I do that? Only does the plastic. Avoid touching the metal tips with your finger while measuring. Okay, yeah, I do get that. Now for BME2, multimeter can tell whether the sensor is powered correctly, but cannot tell whether the sensor is... Okay. Now, my black goes to G and D. Alright, so I think I do need them to hold. Ah, I do need a holder now, right, for experimentation and stuff like that. Like a holder is an ROI, I guess. Okay. Let's hope we get some readings. Right, so got this, we got this. It is getting voltage. What? It is getting voltage. What? It was functioning optimally. What? Another put band? Okay. The other two parts. Okay, how do I check? See. Verify that switch the multi. So everything is working. Then why it's not showing connecting? Oh my gosh. That's why you need devices that allows you to debug the entire bullshit, man. That's why you need devices that allows you to debug the entire bullshit. Turn the power off, switch the multimeter continuity mode. The beep signal. Okay, how do you, okay, continuity mode. Hold. Right, okay, hold this continuity mode, right? If it doesn't, okay. Okay, let me, on that too. It's like the voltage that it's getting is like 3.34 or something. Right, it's not getting everywhere or something. Like if I do that, it's not everywhere. Yeah, but it is getting good amount of voltage, right? So that means it is working too. The ground connection is broken. Ah, I think I need to get the hold, and then I need to one probe on ESP GND. Okay, I'm doing that, babe. I'm literally doing that. I need a holder. I need a holder now. I'm getting like understanding what people do need and what. So I'm holding a GND. It doesn't really matter what GND it is, and GND is second here, so. What is continuity mode and where is continuity mode? I don't know. Like, is it mean by A or something? Okay, what is continuity mode? And currently right now we're working on, yeah, I need to know that. Okay. Okay. Okay, but okay, I'm using unnecessary things you can hear, right? So okay, what is continuity mode and how do I activate it? Like I do send you the picture. Like is it this hold button? Or like what is like yeah. I did check the like 3v3 and the DND. And yeah, the win and the GND, sorry, not DND. Like yeah, GND and VIN on the BME28 and they were like you know, giving signals or something. And everything is wired up. But yeah, I do need to check continuity or stuff like that. Right? And like how do you check and what is continuity and how do you open the continuity mode or whatever? active between these 2 points. Imagine a wire. The points, if the resistance is very slow, meaning the points are connected, it beeps. When you're looking back at the photo, just left a 200 ohm position. Ah, okay, 200 ohms position. Does it show written continuity or anything? Okay. A speaker sound, okay. That combined with this currently mode test type. Okay, could you get a little far away, babe, please? How do you turn off the ESP to never use continue with an unpowered circuit? Turn off the ESP32. I can just plug off this out, I guess. Okay. I should have known that. We show it's not resistance. Yeah, right. It's showing me 0, guys. Checking your VME. Once the board is powered, takes each wire. Black probe to red probe. GND or something. So this GND bad boy here gets connected to this GND here. It's working. Okay, it beeps. This WIN wire here should connect to this WIN. Okay. Now this I don't know, this bad boy here should hopefully it doesn't beep, but it just says that okay, there is some signal sending out, and this bad boy should connect to this. There is some signal there, but if I do that, there's signal even here too. Where are we getting a signal? Oh yeah, it's getting connected to that. That's how it's sending the signal. But it doesn't beep. Okay, it should beep. Okay, the BME E32 is connected successfully, guys. You didn't knew. Oh my gosh. I thought the BME, okay, 280 was dead, but it seems out it is the last thing that is the dead thing. Okay, it's connected successfully and beautifully. Checking a BME wire. It should beep. SDA, G21, beep. SCL, beep. What if it doesn't beep? If the virus is bad, the plug into the wrong breadboard row, the probe isn't touching the middle part of the header pin, the connection isn't really continuous. A useful board tip. Continuity mode is the fastest way to learn how the breadboard is connected, I suppose, yeah. For example, there's a probe to 2 holes in the same row of the bread row. We'll continue. Is pretty much asking. Rather than doing that, how about we do this and check this out or something? Okay. Okay, so yeah, there is some signal, and I think this half and half is connected. It's kind of fun to do that beep beep thing, I guess. Alright, it's kind of fun. So our BME23, whatever they call it, is fucking connected. Our ESP32 is fucking connected. Everything is connected, man. I'm kind of tired, but yeah, you get the gist. Now let me just power on my, what they call, USB. And let me just switch this back to off. Right. Yeah, everything is successfully connected, actually. Yeah, so we just need to upload the code once again, and then we just need to run serial monitor by resetting the ESP32. Right, now once that is done, like, yeah, we wish we should be like a lot better, right? So, gear for tray continuity mode is one of the most safest way. Damage the meter or the product itself. I bet it also damage the product itself. Where is serial monitor? Here's serial monitor. Damn, we got it, ladies and gentlemen. I don't know how. What? How did we got it? We got it. Okay, we got it. The BME 280 was setting temperature. Okay, so my room temperature right now is 26.8, humidity 60%. Pressure is. We got it! Here. We got it. Okay, I mean, I know it's hard for you guys to see, but my fucking keyboard is far away. Plus. Here, we got it. And there's another thing I'm realizing. My mic position is like these kind of mics. Maybe I should have something like this upper way mic or something. Like, yeah. So that like I do not have continuous problem or problem with kind of like positioning or something, right? It's just in front of my mouth or something like that. But it kind of has a really good gain. So if I like, you know, like created like a too far away of my, like, yeah, even if I take it like somewhere here, as long as it's just pointing at my face, it's still, do I say, like, yeah, even when I'm saying in that direction, it does pick up the signal. So I think, yeah, it has a really good gain. So why am I trying to put it in front of my mouth? But yeah, if I like, you know, yeah, I need the positioning to be at my face. That's it, and it works pretty efficiently well, or something, right? So yeah, thank goodness for a great mic that I have. Yeah, so it kind of solves the problem. But yeah, in that when I'm not looking at my mic, like, yeah, the volume should not be really great. But then again, it does get the job done, huh? And it does pick up the signal. Is it the better position, or is that a better position, right? Which one is the better position? I think this one is better position or something. Yeah, who cares? But RBME28 is working, and trust me, I just didn't did anything. Like, I just reconnected like how I connected the last time, right? I just tested, like, yeah, but it still functioned out. So RBME280. Now we need somewhere we can store. Now we need to connect IR receiver, right? It's okay. It's kind of like updating every couple seconds, and I don't want it to update that fast. Don't tell me disconnected. What? Okay, it's updating every second or a couple of seconds. Right? I should stop the what they call, like, the temperature is dynamically changing of my room, and on the basis of position where I put it. So yeah, oh man, it is decreasing. Yeah, the temperature from 26. Oh man, that means like the room is about to get cold. It's 27. The temperature of my AC remote, where is that? Is 26. Oh my gosh, the AC do maintain temperature really efficiently well. Right. And I am feeling kind of cold now. So yeah, it is sending signals, man. It is sending signals. But now we need another thing, babe. Now we need another thing. And yes, you heard it. We need to connect our what? Ah, man, this is like a chemical rush. I can feel it in my head. Ah, finally, man. After so many days, finally got a BME28. It was supposed to be done about 4 or 5 days ago. Like, what do we need as well? Okay, we need to connect our IR receiver. We did got transmitters, and we did got resistors, and we did even got jumper wires for some. Like, yeah, I don't know, but yeah, we did got that. They got that. Right, so we now need to connect our what? What did they say it? IR receiver, right? Yeah, and IR transmitter. So we do need to. I think I can connect IR transmitter really efficiently well. Sorry, not transmitter, receiver. And I do have a what they call it, high quality IR receiver or whatever they call it. Yeah, here it is. Shall I use a new one? Like, this one's like, yeah, I kind of have a hard time trusting it. But yeah, if this doesn't work out, we may end up using the new one. Like, so we just need our, like, what was the IR receiver coding was? Like, okay, let me just open SearchGPT and out of chat. Okay, guys, what was it again? I'm kind of forgetting. I just need to search, and I just need to type IR. Okay, fuck, it's not working. Yeah, their search is kind of like lags a lot, so that's kind of problematic. Not shift tabake I R shift tabake R IRA नहीं IR receiver. IR receiver has what? 3 pins. So we have like a shift 3v3. Sorry. 3v3 connected to like a. As soon as I write 3v3, that's like a really unlike 3v3 DND, 3v3 GND, GND, BME, BME. Rail, okay, 3v3 win, DDNP, USP, DN2. Yeah, so this is where my IR receiver is. I just need to know what position we had. Recommended male-to-male jumper wire. Okay, so if I get this here now, right to my breadboard, like let me just connect this to that. Okay. I don't think so. Male-to-male jumper. I think male-to-female jumper wire would work better with this bad boy. I'm not gonna lie. Yeah. Where are my okay, I can just open this up, but no, I don't wanna, but let's just open this up too, since we are opening everything up. Guys. Man, today we are gonna connect everything, even if it takes 11 a.m. Okay, that's just an exaggeration. I don't really work for that long, but you get the gist. Okay, where is my male to male? This is male to male. This is female to female. This is male to female. Okay, I just need this stack here. As for the rest, we can just go downstairs. And I would add some other stuff too. Right, so how many do we need male to female? Like, we need a couple of them. At least, just 3 of them. Not a lot. Actually, I should use the open ones, but, like, you know, they are like, yeah, man, I should just use the open one. Let's just not waste the new material, right? Actually, fuck it. I just have to open up the drawer or something. I need to get another drawer here. Yeah, I would buy a drawer. Actually, let me add that to my to-do list. Buy. Right. Let's just add a task, which is what shall we buy? A big table, another table. Right, and then we need like a shelves or something, like, yeah, I get it, like, yeah. I don't know if that was sleeves or shelves. I pretty much got the spelling wrong, but you know, who cares much? I mean, you care. If you care, that's sad, man. Why do you care that much? Okay, so now I need to check continuity or something. So this is not powered, but yeah. So it will send like, yeah, some signals. Could you please fuck off, ESP32, buddy? Okay, everything, 3 of them is connected, or kinda connected per se. Right, and now we need to like get them like a really, really awesome position or something, right? So we need to get them like in a. Yeah, I do remember. We need another male to what they call. Yeah, female to male works a lot better. Male to male works in some cases, right? But I think when you are building complex builds, I think you need a. Right, so we've got another connection. Let's just we are not going to test it out yet. So how did we used to connect it? We just need to like get this here. So we need to get these two there, and we need to get this like a. Right. Yeah, it should test IR receivers now. Okay, I guess, man, BME 228 is working for a long time now. If I connect this to like there, I should be able to see some connection. Let me just turn this off for a sec now. Which literally means unplugging it or something. Now lose the Android IDE, lose the connection with the. I need to update my like a code for I guess like everything, I suppose, at this point. Where's like here it is, SaaS business, right? So let me just put it here. Some of the stuff on here at this tab, right? Soldering station. Okay, we were in this chat like talking about okay, so I have like only right now like the code that I'm using is just only for what they call BME 28 or something. Like yeah. Copy Control V, that's like simple as like yeah, so now this code is like a really big code compared to the old one, and it gets the job done, right? So you have in this code you have like IR receive pen output, right? ESP with 2, okay, IR receiver started, IR transmitter. So we have IR receiver done now. Now we need a what they say IR transmitter, right? Like first of all, we do need to check electricity passing, so we do need to like I need to check if like if I send like a signal from 3v3, does it connect to like here? Okay, now I need to check DND. No, DND may not be connected. Okay, now I need to check. All three of them are successfully connected. They are supplying. Right, so if you just yeah, and now we need to like how do I connect the IR transmitter or something? Okay, my laptop is lagging now. I don't know why it's lagging. I mean, it's just the same thing. Oh, maybe like a lot of tabs are having a toll on it. So it's not that laptop is lagging. It's like a Wavelink has a hard time. Okay, it's heating up or something. When it heats up, it's a hard time of like, yeah, and it heats up easily when you have like a multiple monitors connected, which is kind of a pain in the ass, honestly. I'm not gonna lie. So now what do we need to do is like maybe cool up the Wavelink. Like Wavelink needs air for it to pass down, right? So I think we can do something as specific as that, right? Like connect that, get them connected, or oh, I can actually decrease the room temperature. I can just pretty much imagine just how much heat these things are producing. All right, And how do I connect IR transmitter, right? Once again, like how do I connect the IR transmitters? We did have a communication about that too. So like so it's like I can actually have this. There you are. And like shift IR transmitter. Branch. Okay, this is the thing, I suppose. Right, guys. I'm sorry. No, this sends the entire code, but and actually, yeah. Oh, as soon as I turn on AC of my room, for some reason, wavelength starts to work better. What? What? Okay, so it cools up really fast. Fuck, that means if I'm in a okay, if I directly provide coolness to it, it works. What? Because it cools up fucking fast. What do you expect, huh? Maybe that's okay. I don't know if that hypothesis was really true or not, though. So I receiver started, I transmitter started, temperature, I received. Okay, I do have IR remote or transmit, like IR. What is the name actually? It's IR. Sorry, it's IR. Uh, remote. ES IR remote ESP32 by 826. Right, and let's just install just this just in case. Like just in case, guys. Who knows? Like fuck, anything could actually fuck you over. Yeah, it just literally takes 1 second to get the shit installed. Then set up. Yeah, it's lagging again. I think it kind of like cools up, and when it cools up, it stops lagging. When it heats up, it starts lagging, which is like a big problem. Yeah, but I do feel good about now blocking that guy. That guy literally destroyed like discipline of mine. Fuck, that was cruel. Like blocking like my first viewer or something from my own stream, but fuck them. I mean, like I'm not obliged to answer trash questions, right? I'm not obliged to answer trash questions. But honestly, I didn't dislike them. The answer was like, yeah, they asked us too many trash questions, like to begin with. Okay. Just tell me, how do I connect the IR? I do have everything, like the transistor and I'm sending you the photo of everything, and how do I like the everything. I already have the tools. So I have an IR LED. So I do have different types of transistors. I do have I don't know what the collector is, but yeah, I do have ESP32, like you already know. I do have like a resistor or something, right? But you still need to explain me from start to end. Actually, how do I connect all of that, into one system? And first of all, I need to just let's just upload this to my. Shall I rename this bad boy? No. It is uploading. Okay, it is uploading, but it's not detecting compiling scratch. Actually, yeah. How are you uploading when dev module is not even connected? Yeah. Yeah. It depends on the wavelength cooling. Or I don't know. Wait, what? It's not showing any response? Damn, it's laggy too much actually. Or maybe what if I take all the complex tabs, push it here, alright, and take this Android IDE or something here. It's just running one IDE or something, right? So you have the app right here. So now you have all the chats on the main desktop. Ah, that space. Oh, that frees up the speed. Okay, so now it doesn't have to transmit all of that. Right, but that kind of like makes it like I literally wanted that to read stuff, and now I can't read stuff because okay. Your transistor, the power. Yeah, that's another project in itself now starting once again. The best part about ChatGPT fucking able to hold context till this point. I mean, yeah, it does forget a lot of things that happen on the start, but yeah, it's like we have like a 300 plus communication and it's able to hold context. Just imagine in a year or something, it would be able to hold context across all chats, across all topics, like you have ever said. Like its memory would be non-linear, right? So it's like, damn, that would be insanely like I don't know, like effective, guys, in terms of like a lot of companies in terms of learning specifically, because ChatGPT would able to map out what you know, what you don't know, what needs your predictive model the best updating or something, because it knows for the last 5 years or something. Like it's like I have more than 5,000 or something chats. Like that's like no, or even more that I've collected. Like yeah, over the years, not 5,000. That's maybe an exaggeration. What? Maybe I should actually get this to off, right? It's unnecessarily, yeah, man. It's unnecessarily powered, and it takes battery or something, right? So I shouldn't get this. Okay, that man, that can actually destroy a lot of things I have here. So yeah, man. Like yeah, I could ask ChatGPT too. Okay, what memories do you hold about me? Or something. I think at that time, like it would be able to update memories. Oh my gosh! In the future of ChatGPT is like yeah, it's one of those things that you can use so much to learn, to understand, to like yeah, to get asymmetries or something. Like yeah, first of all, you guys don't need to see that. You can just see this, right? And I need to just increase like yeah, the plus sign of this, and this why is this fucking shit increasing? Okay, I get it. It's like they're connected or something from the same tab. Well, I don't really care if that increased, let this increase too, or something. Yeah. So I have this. Right. And damn. This is not the one I want. Right. Okay, I just can't see anything. They have such a small. My mom called. Thank goodness my phone was on Do Not Disturb. I would have gotten really disturbed by her. Okay. You have 2N, 2N22. Like, yeah, this is what we need actually. This is like the one thing we need. As for the rest, they can just go to hell. Like, yeah, we have BET. These are actually organized. As for the rest, nothing is kind of organized, man. This is like a problematic. This shouldn't be like this. Or I think we need this one the most, so we are taking a photo of this shit. Too much light destroys detail. I see. What different values are there, honestly? 2 in this another value. This is different than that. 3 in. Right, and we can have like a in future learning without AI would be kind of stupid or something. Yeah, like if you're not using AI, what are you doing? IR, LED transfer, front and back, if possible, your transistor 2 and TB and TC. Current breadboard with ESP2 receiver still connected. Now it's time to upload photos. SaaS business. You can add photos like, yeah. And I didn't keep the paper. Not this. Where was that? Yeah, here it is actually. No, not this. The paper that contained this was this actually, specifically, right? Oh yeah, it is written up here. Okay, so value of the resistor is 220 ohm, 1/4 watt, 0.26 watt, plus minus 5% tolerance, 220 mR, ohm MF. Something like that is written on the yeah. So I think that is what resistors are, like, or the values they have. Like I've sent you 3 different types of what they call transmitter, right? Not transmitter, okay, transistors, right? And I've also sent you the photo of transmitter, right? Like there's only one IR LED transmitter, like, yeah. and I have connect as for like how I've connected breadboard. It's simply like male to female to male jumper wires connected to the breadboard, which is directly like on ESP32, which is connected to like BME28, right? And those same wires like are also connected to IR receiver, which is functioning pretty well without any problems. Now I need to check the hypothesis if that is actually working or not. So we need to upload first, like if like our So I'll come back in a second from washroom, but yeah, it's good upload till then. Right, okay, yeah, so ESP2 is now connected. Now we just need to add our senior monitor sketch. Oh yeah, it's really smooth when there's only one tab. So it's like having a hard time when there's multiple tabs open. Like, yeah, that's what my wavelength, because wavelength is still heated though, but it's at an insane high time when I have like 10 to 20 tabs open. I see that, so yeah. So I didn't need more RAM. Okay, IR signal sent. I think I do need to reset this bed point for a sec there. Okay, let me just try to receive an IR signal. It's saying that it said send it an IR signal, but how? It should show that it has received. It has received unknown bits of information. Yeah, because AC sent entire packet of like a Panasonic. Yeah, it says MVM. It's also actually receiving what they call from nearby area. Someone else is like using a Panasonic AC in someone else's house, and it's kind of receiving that. Don't tell me that. Or is it like an? Okay. So we have guys. So we have got our IR transmitter running. Sorry, IR receiver running. We've got our BME 280 running. We've got like I don't know how it's like IR signal sent, but there is no IR signal sent. Like there is literally no like what they call. How is it sending IR signals when there's no IR signal? I don't know. Yeah, but now it's time to connect the thing, I suppose. So yeah, that's working too. So tell me, how do I build this like step by step? Don't actually skip a step unnecessarily. Like yeah. Don't rush the entire explanation because you have a limit to actually, there's a chat limit, but yeah, explain me everything and like how, not explain like the science behind it, but just like, yeah, how it needs to get done. Yeah. Mm-hmm. Yeah, man, it is. Though I don't know how it's sending like IR signal sent, but yeah. But it's time to connect this thing, so let's just take our serial monitor offline or something. Right. So our serial monitor is kind of offline now. Oh, I can do that, but I'll think about that later. I mean, it's GND. Everything gets connected to GND or something, right? Like we need again mail to And as for the rest, I think we need just this and this. As for the rest things, like yeah, let me just collect them. They're kind of useless as of now. I think learning hardware for my first billion-dollar company, which is memory, would be very efficient, right? Okay. A lot of people would say, "Yo, what? You creating a billion-dollar company? That doesn't make sense." I'm right. Yeah, you are right. It doesn't make sense, but yeah. Ah, I got the wrong transistor. Ha, I got the wrong transistor in. Mm-hmm. 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 No, I'm not gonna get that easily. Now I need everything to come out or something. Yeah. It's like a lottery. Damn, are you shitting me? Two and yeah. So these we are gonna get two of them, just in case if something doesn't work outside. Mm. Yeah. So we need like emitter to GND, right? Yeah. We need three, if not six, males to female wire. I guess yeah. That's what I use the most in my projects. Because like these thing doesn't directly connect, I suppose. Mm-hmm. Let's just get that. So we've got first this receiver. Right. Yeah, we've got the transmitters and stuff like that. So three of them in three different positions. Like yeah, so this is how it should be, I suppose, right? To some degree. Yeah. Now we need to add a emitter to our ESP-DNG, which is this white line, right? Okay. White line goes there. That means it's in the second, of course, or else it would be. So this is where we have like a what they call like here. Right, we have this. Yeah, so that is connected to that. Now D4. B3, D4. Where is D4? Okay, I need to now connect D4, so that would require another male to female wire. We need what? D4? D4 here. We have D4. Now D4 gets connected there. Where? The D4 gets connected all the way to there. Yeah. Now, which one? Like, yeah, the resistor. Base is the middle, right? Emitter, base, collector. Mm-hmm. Okay, so this should work, right? Let me just send a signal and check if that works or not. Mm-hmm. D, G, and D, and purple, right? So if I send from here to yep, they are working. Yeah. Now resistor. How do you even use a fucking resistor? Okay, man, maybe I'll break the fucking, I don't know, resistor. Another jumper wire. Okay, the complexity is scaling like a lot. Right. Now this resistor. Base is in the middle. So other side goes to main. So we need I unnecessarily connected things that shouldn't needed to be connected in fact. Right, but I don't think so. I did that specifically. I mean, I can just directly connect them or something, right? Yeah, right. So throw it off. I can just go with what they call male to male. Male to that's not male to male, female to female jumper wires. Yes, there it is. Like yeah, my first time using a female to female jumper wire, I suppose. Right, so now this should go here. And that should go there or something. Now we'll check it again if everything is working or not. So we'll go with this, we'll go with that. We'll just try to apply some electricity here, and we'll try to receive if that is like a, if we do get a response from there. So yeah, here we have our first sense of electricity. Okay, maybe we should okay, yeah, maybe I should like not do that from D, I should do that from D4 to That means somewhere in between we got some back connections going on. G and D has a wide line that goes there. Right, and that wide line is connected to, I'm not gonna lie, two things already, which is like our receiver and then PME in the mix or something. I do get that. It's like, yeah, and that goes on to directly our IR receiver. Right. So that is there, so we can say G and D is connected successfully to this. But then we have D4. That is like gray wire, which goes there. And that gray wire, is this the gray wire or is that? So the gray wire is connected to our, yeah, which goes into our resistor. Let's hope it works. Why? Only this can actually tell us. Where is my using multimeter? Okay, I do a lot of testing, and I'm now getting. I do a lot of testing, actually. I do a lot of testing, ChatGPT, and now I'm getting some gist of it, like how is it functions. But there's one thing, I do have a resistor right now, and that resistor is connected to a transistor, right? And what I did realize, if I check the continuity with like one side of the resistor wire, which is connected to my ESP32. So it's simple like this: ESP32 is connected to a resistor, and that resistor is now connected to like what they call a transistor, right at the base. Right, and what I did realize is like there's one side. I try to check all different paths. So ESP3 to the like a resistor. There is electricity continuity going on, and I sense it like but just the other side of the resistor, there was no like nothing. Like when I was sensing, I wasn't reading anything. So why is that? Like I directly tried to check the base with my D4 on ESP3 too, and it wasn't showing. So I was like, okay, where's the connection is wrong? So I tried to think, okay, is the connection between the resistor or that is broken? And then I realized, yeah, the connection between the resistor and the transistor is broken, right? And what I did realize is like one side of the resistor is connected to transistor and there's electricity definitely passing there, right? And one side of the ESP32 and the resistor is also connected thoroughly, and I can pretty much guarantee that at this point that they are connected. But if I take one side of connect my one nip to D4 and another nip to other side of the resistor, it doesn't show any reading at all. Like, why is that? Like, it's like a resistor like blocks the what is even doing? Like, yeah. Yeah, this should give us an explanation as to what is happening, but let's just go back to our learning preference. Yeah, that's like a layer. Ah, I get it. The other side of the path becomes. Ah, the 2000 ohm. Set the 2000 ohm. 2000 ohm. I sent that, and now I should be reading. Okay, so my function. This machine doesn't even have an option like that, I suppose. Ah, each end of the circuit. Okay. It's okay, so it should be something like 2K. Okay, it's just that okay, it's working. We don't need to actually check. Okay, man. Sorry. Base all separate, now connect the ground and mirror. The other base IR LED, like one leg is longer, one leg is shorter. The long leg is out, the short leg is. No, I haven't done such a stupid thing of like cutting the thing or something. Collector. So now long leg is goes to 3v3, right? 3v3, okay. Where is my where's my here it is, the mail, so yeah. Connect the long leg to let's check. There is a connection. Right, so there is a connection there. Now short leg to collector. Right, so where is my male to female to providers? Well, actually that's a really long thing I broke there. Yeah. I should connect the short leg with what? Why are you looking at me like that, babe? Yeah, short leg with connected with collector, which is like the third or something, I suppose here. Yeah. Now we've got the entire thing done. We've got all the manicure, anicure, and senicure. I mean, why it's in here at this point? 3v3 long leg. Yeah, 3v3 long LED. Now I need to check if the connection between the with the short leg and yeah. Okay, so they are connected too, man. Final warning. Okay, what is final warning? EMP3420. Final wiring. Okay, not warning. D4. The resistor, then the base, the 2 and 2. G and D, short leg, AD. Don't point it anywhere yet. Control C. Okay, this is the program that I'm currently using on my Android. Okay, so this is the program I'm currently using on my Arduino IDE. Okay, Control Shift Enter, Control V, Shift Enter. If there's some changes that we can make to this program, we can make that. But I think it's pretty much correct or all right, right? It checks everything: BME, IR receiver, and IR transmitter. Oh man, I feel like shitting. To add to it, yeah, simply. Okay, generate like a final asymmetric. Okay, generate the code for me right now, like a final code that is actually like professional and not just professional. Actually, have the most info like working asymmetry or something that means it work efficiently better or something, or efficiently well at doing its job and sensing the transmitter or something. Like yeah, like the logic behind should be solid. Okay. So now we'll get that too. The code. Having it repeatedly transmit our signals. Okay, I'll copy this for now. And like a Control A and then Control V. I'll paste this. We'll upload this thing to our serial monitor, like this code, right? And not just upload, I mean, we'll first connect to, Now, if everything functions right, we have got like, yeah, everything becomes so easy. I'm not gonna lie. After I received this, this thing, whatever they call it, like everything. I'm gonna go and maybe pee or something. But yeah. Damn, everything's working so efficiently well. I feel proud of myself for now. Like, yeah, literally. Okay, it's now booting up. Okay, so the booting up is done. Okay, now let's just reset the serial monitor, which takes less than a sec. USB to monitor control 1 ms, CPU itna, flash size 4 MB, heap itna bytes. Okay, I initialize our sensor itna itta sensory data, sensory data, sensory data. So it's like it should receive I guess, signals. Number of bits. I don't know. Okay, so IR receiving is pretty efficiently. We just needed to send. I just need to go to washroom real quick, and I'll be back in a couple of minutes. Okay? Like yeah. And I'll listen to some song and vibe out. Or maybe I should go for the lunch or something, guys. Like yeah, I should go for the lunch too. And then we'll actually make them take the data, like take the information from the IR receiver, and then send it to our, like yeah, something like that. Okay? I'll come back in a minute or something. Yeah. Okay, guys, I'm back. Um, yeah, man, that's kind of like so now yeah, what I'm doing is like I'm trying to dt by dx. So it's like with respect to time. Times it's like yeah, so it's like dt by dx. So it's like yeah. If you can have that, then yeah, once you can calculate dt by dx, you can pretty much predict under what condition, at what rate the temperature changes. And then, so it's like once you can predict that, so it's like under what conditions the temperature changes, right? Or something like that. So yeah, I mean, so it's like, yeah, under what condition? Under what condition the temperature changes? At what rate? If you can know that, you can always AOT or something like IoT or something like IoT, or they call it AOT. Like yeah, if you can know the rate of change, if we can know the rate of change, we don't need to know the environment. We don't even need to the environment. So it's like, yeah, we can use that to know how fast the room cool up under certain conditions, and how slow does it. Yeah, man, that's like a genius idea. I'm not gonna lie, that's like a genius idea. If you calculate dt by dx or something. Rate of change with respect to time. So how is like a thing is changing? cost hardly like 400 rupees or something. Like the first prototype, except the BME2. Like if you remove the ESP32 and that. So if you move towards a hardware company, right, guys? I mean, like, yeah, that would be good. I mean, if you can just get one BME28 sensor in a room, that's more than enough for us to calculate ED by dx, and that's more than enough as far as to know like what is the rate of change under certain conditions of this room. So if those conditions apply, then you can pretty much set the temperature perfectly, man, perfectly, or something like that to some degree, I suppose, right? Yeah, we can know that. Move up under certain conditions. If you can know that, don't even need to know the environment. Like, yeah, building the software would be, yeah. Yeah, man. So like that's like a rate of change or calculation, air movement, sleep time, like clothing insulation doesn't really matter. A lot of like once you get the rate of change, what happens is like once you have a like a rate of, this is like creates a baseline prediction, and once you have a rate of change, okay, this is how fast the room is heating up, or this is how fast the room is cooling up, and this is like the ideal temperature under these conditions this person needs, or according to like his information he should need, right? It starts to set that, like, you know, kind of constantly changes the temperature quickly to set or maintain that ideal temperature, right, for that person. It tries to minimize the range of the ideal temperature again and again or something. Like, yeah, we can actually definitely have that, right? Yeah. So if you got the rate of change, we don't even fucking need how hot or cold the room are, and the rate of change can update, always update simultaneously. If the rate of change is high, we just need to, like, you know, change the, like, yeah, we do not even need to pay much attention to what the wall is, what the size of the room is, or anything like that. Like, because what thing matters was like the wall thickness, the size of the room, the sun, like from the where the sun is position is coming from, like how fast, what the materials the walls are made up of, right? All the different kind of stuff doesn't needs to be calculated because we know the rate of change, right? So it's like a person do not, like, those were the things that we needed to know in order to actually calculate. But if you can just know the rate of change, and rate of change changes dynamically, so whatever the time of the day, as long as you can calculate the rate of change, and you do not even need those things to calculate the rate of change, all you need to do is like have a sensor that constantly track how fast the temperature is, like how fast the room is heating up or getting cold. You need to calculate that change, or the rate of change, or like how hot or the cool the room is in a moment by giving those parameters. But you don't even need those parameters. You just need BME28 in a room or something. That's it, right? Yeah, so that's kind of like insane. Once you got the rate of change, the only variable, like if the rate of change is fast, let's say if there's a laptop that is heating up in a room, or there's a phone that is getting, like, yeah, the rate of change is, like, the rate of change changes, right? As soon as the rate changes, a rate of change, or whatever they call it, changes, then the best part is like the best part is like, I don't know, like okay, I don't know, but it's like the rate of change changes, right? So if like the, yeah, the rate of change. Okay, what are the variables that rate of change kind of like eats over, right? The variables. It's that rate of change eats over. That means it's a compression. It's a compression for rate of change. Okay, what's happened? Maybe I accidentally pressed page down. So it's like the position of the sun, the size of the room, the heaters, like phone or some device, right? So it's like a phone, like laptop, like, you know, you can, like phone, laptop, and like, yeah, laptop or kitchen KITC, kitchen appliances. The heater, like laptop, like the heater, like phone, laptop, or kitchen appliances. So this is also eaten up, the size of the room, the position of the sun. So yeah, we can get the heat of change, like, yeah, the rate of change all the time. Position of the room too. And because of that, we got indoor temperature for an actual tracking. Indoor temperature for accurate tracking. Yeah, so we can just calculate the rate of change and everything. Like, yeah, I do need feedback from ChatGPT. It's not because like I do need feedback from both. Like, yeah, that too, and I do need feedback from my buddy ChatGPT or something, right? Laptop, right? And how fast I heat the temperature? If it's heating up fast, then you must cool it fast, right? And maintain ideal room temperature, right? Or something. Which is for me, it's somewhere around 24 to 28 or something. Under the changing conditions, right? So body heat. Like the hardware would cost not too much, right? Man, I have to build a fucking hardware company or something. Like, yeah. For that, I need to hire engineers and then I need to hire designers. That means it becomes a startup. That means I need to, like, raise some funding, at least, like, a couple lakh or something. Yeah, designer to design my first prototype, I suppose. Like, like someone who can design hardware or something like that. So, right, and then we need like a lot of stuff. Like, yeah, this is spiking uncertainty for me, I guess, which is not a good thing. But yeah, because I'm thinking more about the future now. Body heat, like, yeah. What else? Like, what else does it take? Like, yeah, if you have a kitchen appliances, anything that's in the room, like, it's just like, it's just 220 ohm resistors, right? By the way, yeah. So you just kind of keep track of every, like, yeah. So you get a system that is pretty hard to fool and can actually suggest or choose like the appropriate temperature in any settings because it knows the rate of change, and it just knows that it's like, and it can check humidity or stuff like that too. So like, yeah, I mean, yeah, damn it. Now it should update, by the way. Like, Android IDE is constantly receiving signals, right? Like, yeah, 25 or something. So what did the temperature reach? The temperature reached about 24. Okay, when I reached like 24 or something, that's when I feel like I'm kind of like, oh yeah, it received the signal too that I just sent it right now. Right, the temperature reached 24 or something. Now it's kind of like increasing again because I set mine to 25. Like, okay, I sent my room. I sent the AC to 27, but even then I set the AC to 27. The room temperature was actually around 24 or something. Like, yeah, and what is the ideal? Like, yeah, that's what, like 21 or something. 21 to 24 is like, yeah. Okay. I just need to collect some data actually on this, like some level data from ChatGPT. So ChatGPT, what is the approximate room temperature that we humans have, like, or humans want or something? So ChatGPT, what is the approximate room temperature that we human needs? Like approximate everyone. Like yeah, right now my room temperature was 24 or like 24.69 degree Celsius, and I start feeling cold, and I then changed it, and now it starts increasing, right? And I think it reached like because I have BME28 connected to my laptop, so I know like how like what the temperature in my room is. But I still wanted to know like what is the like this is my I realized like okay, even though my AC was set on 26, right? The sensor was showing 24, so I guess like yeah, the AC is kind of like cools up a lot more than it shows or something. All right. And maybe because I was getting directly hit by the wind, like yeah, so I wasn't sitting in the corner of the room. I was directly hit by the like yeah, so it's like in this area, like yeah, oh yeah, sitting in the position of the room, right? Yeah, that matters too. But yeah, then again, what is the ideal like yeah? Sitting what position are you sitting at? Like the more the tabs that are open, the lagger it runs. The game is at now, right? So if they say okay, really bad, we kind of like start with 24, or like yeah, this we kind of start with this, we kind of start with this. Often, if the humidity is around 40 to 60%, many stand in place thermal comfort around 20. Clothing in the air movement. Why did you feel cold at 20? Sitting still at your laptop, you produce less body heat, thin clothing. Mm-hmm. A DT by DX system, like a system that constantly. I do not want more updates on my temperature for now. Like yeah, so I think yeah, it's just running up unnecessary data. Let's just not wire all of them. Mm-hmm. I think one of the most or the biggest important thing or the variables I should calculate in my business is that like dt by dx. I've learned this concept from physics, right? But I don't know much about it. But the idea is like that's what you have to tell me. But the idea is like calculate the change in temperature with respect to time. That's pretty much it. So what that does is that it gives us the position of the sun, gives us the size of the room, the thickness of the wall, the position of the room in relation to its environment, like the here and the phone, like laptop, phone, kitchen appliances, like the body heats, the person information, like because like yeah, the person's like the body heat that every person has is different. So we need person information to calculate body heat. But now we don't have to do that. And what position in the room you're sitting at to some degree also gives us that idea, right? It's like, but then again, like what I'm trying to what I'm trying to say is like once you got the dt by dx, it's like the or like yeah, the change in temperature with respect to time, you can pretty much calculate, like you do not need to know any of these variables, right, which influences the room temperature, because like yeah, you can pretty much know like what the changes in temperature, so you know that under this context you just need to know the context, right? Under this context this person needs this temperature, and then you can find almost optimal temperature for every person if you have dt by dx, I suppose. Or is that an overreach? That's what you have to tell me. Uh, टेम्परेचर क्या रीच करेगा और टेम्परेचर क्या रीच करेगा उसके रिस्पॉन्स पे Guys, I'm walking by the way. I'm walking. I think you guys can see me walking. Oh, you guys cannot see me walking, but I was walking in the room all this time actually. Yeah. I don't want you guys to see me, but the gist. I'm just walking in the room. But you know, you can do all of that, but bit of change. Ah, 24. तो मेरे को इसकी लिमिट करनी है, उस कॉन्टेक्स्ट में कितना सेट करना है और उसके बाद सोल्यूशन अपने आप आ जाएगा क्योंकि किस कॉन्टेक्स्ट में कितना सेट करना है, लाइक दैट इज द बिगेस्ट, लाइक या किस कॉन्टेक्स्ट में कितना सेट करना है. बिकॉज अगर मेरे पास रेट ऑफ चेंज है तो मुझे पता है यार, मुझे मेरा कितनी तेजी से चेंज हो रहा है, क्या रूम टेम्परेचर है, क्या इंडोर ह्यूमिडिटी है, और मुझे पता है कि आइडियल लमसम की बंदा क्या प्रेफर करता है, इसकी पास्ट रिस्पॉन्सेस से एक तो बार के कि लमसम इसका आइडियल है जैसे 22 या लमसम इसका आइडियल है 24 या लमसम, बिकॉज लाइक वेराइटी है क्या, एक बार आपने सेट कर दिया और उनका और फिर घंटों तक, और फिर लाइक क्या रेट ऑफ चेंज से ये भी डिटेक्ट कर सकता है कि किस रेंज के अंदर इस बंदे को प्रेफर होता है रूम टेम्परेचर. तो जैसे ही मैं रेट ऑफ चेंज उसको पता चल गया इस बंदे का अप्रॉक्स, तो आईवीटीबी कैलकुलेट नहीं करना पड़ेगा, आईवीटीबी फिर मां चुदाने गया, राइट. आइडियल बॉडी टेम्परेचर मां लाइक आईवीटीबी क्या so so we do not need ideal, like yeah, we do not even need ideal body temperature. We also do not need IBT in this system. This system is very much IBT. We do not even need IBT. AC voltage. Yeah, we do not even need IBT or something. So so it's like, how do we get this stuff done? Get this stuff done. It's kind of hard to, you know. I just need context and this person's like approx prediction. So we just don't need IBT, but we still need initial baseline prediction or something. So we do not need IBT, but we still need what they call it? We still need initial baseline prediction. Like yeah, we don't need an accurate IBT. We need an accurate IBT. We just need a baseline prediction. Yeah. Need an initial baseline prediction, that's all, right? Once the baseline, once the initial baseline prediction is set, or the need, I mean, we can negotiate with that, and then I will contain that to basis of your response or activity or something. So just remember the context. So how much you are changing in the what context. That's what remembers or something. Yeah, it's like a upper bound and lower bound. Symbol of it, and then yeah, so it can maintain itself by itself. Right, but it's like AC can never really go out for the heating or stuff like that. So but you can sell this idea to AC manufacturers, and then they can have like a system DT by DX or something that calculates this stuff. And like, yeah, man, yeah, the only reason like this startup is successful is because no one has actually even thought of doing that, let alone did that. So once you can calculate the what like the like DT by dx or something, what happens? It just costs not even 1,000 more rupees to add that into the system, and now you have an AC that automatically regulate itself on your prior preferences, right? So it's like, yeah. So it learns from the prior preferences, and even if you change, sometimes it will still automatically retain the, yeah. If more people comes, it will like, yeah, try to hit that target. If there are really less people, it will try to hit that target or something. So it will always and always try to, yeah, reach the temperature or something. Like, and it depends on the position too, like where it is. So yeah, if more people, the heat starts to rise up, the AC constantly change the temperature by itself to maintain that or something, because it knows the IVT, like almost like what you prefer or something under what context. Yeah, and the best part about humans is that there's not much difference in context. Aha, that's the best part. The best part about humans is that there's not much difference. Like there's only 22 to 20A. And if you have like somewhere about 24 to 26, like if you have somewhere at that range, a lot of time, like you are gonna hit the right, like you are gonna hit the nail on the head. It's not because like you are genius, but it's because like human can have certain various, like yeah, you can, even if let's say I can tolerate like a room temperature of 22, right? Like for yeah, and someone else can tolerate even a room temperature 26. It's like we have some, like yeah, there are some things like yeah, we can tolerate or something. Yeah, that's why the system works so well. Even in large bases, automatically by itself. Yeah, man. But first of all, we need to test our transfer right now. But yeah, I saw it reflexing. Yeah, yeah, man. T by dx is powerful. dt by dt is powerful. Let me plot. What is the current temperature? I felt cold. What was the current temperature? Like, let me just quickly connect the ESP32. Let me just quickly connect that. Let me just quickly activate my Arduino or something, that boy. Let me just quickly press EN. Let me just close this real monitor. Let me just, I don't know, upload. And like, I lose some, like, yeah. Let me just go to tools, serial monitor. Let me just keep on running like that, actually. Let me just keep on. Oh, fuck. What the fuck am I even doing at this point, man? But by the way, I could actually come here and go down here again. Right, because I think that's what you guys want to see, or that's what everyone's want to see at this point, right? So, yeah. Okay. It hit at 26, but humidity changed. Oh, changes in humidity matter too. Humidity is changing of the room. Yeah. Is humidity increasing or decreasing? Oh, humidity is increasing? Wow, are you shitting me? I mean, more humidity there is, like, I don't know, but yeah. The fundamental elements of what the black box software approach can achieve. second order Hibachi cook, guys. Not gonna lie. This is just bullshit. What Gemini said is bullshit, and let's see what. Yeah. Yeah, humidity was rising. Let me just quickly check. The humidity increased from all the way. Now I'm feeling heated out of nowhere. Even though I was just feeling cold. Yeah, humidity is reaching all the way to 70% or something. Yeah, so when humidity increases, temperature increases, man. As the humidity kept on increasing, the temperature kept on increasing. Or humidity, temperature both kept on increasing because of sunlight, maybe. Yeah, the sunlight is the only. My laptop is heated, but not that heated, so now I have to decrease the temperature 1 degree Celsius, right? Yeah, IR data, right? So yeah, now I need to just generate code, right? It's heating up. Wavelengths also heats up, right? And then it cools up, and then you have to okay. Yeah, so temperature is falling and humidity is also falling. I need a simple answer, which is like, does humidity affect temperature of the room? Okay. Does humidity influence temperature of the room? So like, okay. So like my hardware is connected with Arduino IDE, right? And like, can I use anti-gravity IDE to actually code and yeah, paste that code to like Arduino IDE or something? Or connect like any other code editor directly to Arduino IDE or something, so that I don't have to like copy paste the code or something, and like the AI would be able to like so that I would be able to wipe code or something. You see what I'm saying, right? And how do you create, like, let's say I want to create like a dashboard or something with like my like yeah, by writing code on Arduino IDE, right? Like, how do I do that too? Like, let's see if it's supposed to not create an. Right, guys, and like Arduino Element, Android Studio, Android IDE, autonomous room temperature controller. I feel like deleting it. Now you'll say, why, Varric? It's kind of trash. So yeah, yeah, deleting the entire thing. I wipe coded that, man, by myself. Okay, shall I open folder? I'll select this one again, but yeah, from so. Okay, there's lots of stuff. Cancel. Let me just delete that once again. Ah, fuck, I crossed the wrong. Shit. Or is that Windows E? I'm using basic multimeter. Ah, yeah. For example. Ah, schedule Julia. Okay. If I yeah, right. So what we did, we kind of like, okay, wait, what? Oh, we opened up a new sketch, but we do not need a new sketch. I just need to open folder. So this is like Arduino document. Okay. Sketch Julia. Okay, and then you have Julia sketch. Okay. Here we can add a new folder which says like a new folder, and then we can like create like that folder as like a hardware uh code system, something like that. No, call it like, what is this, a hardware to like, yeah, so we are like a hard, so this is like hardware to software system, right? So this like connects hardware to software, so we'll just call it hardware to software system or something specific to that, and then we'll open up like an anti-gravity IDE. Yeah. Yeah, the files are of course deleted by me, so how there would be any file? Okay, do I have to manually cut all of them? Like what? Like, is there nothing like close all? Close all, yeah. Right, autonomous room. Like, yeah, so rather than that, we can go like open errors. No. Like new folder, reveal, open and integrate, add folder to workspace, open folder, remove folder, find path. I mean, like, yeah, let's just like, you know, I guess if I close my, what am I actually selecting? Like, yeah, I'm accidentally closing up the shit that doesn't needs to be closed up. All right, so what is that? How do I open up a new what they call editor setting extension, open keyboard shortcut, which the task? Workshops. Ah, yeah, new text file, new window. Finally, man, finally. Documents, Android IDE, get Julia, hardware to software, select folder. Now, yes, I trust the authors. Right, and what we should be able to see here is like come again. yeah, I can just give it the context or something hardware to software, but um, I should take my skid Julia and put that skid Julia into like a, like I should connect my hardware first, disconnect my hardware first, right? And I should just cut that and paste that into my hardware, right? Skid Julia, all right. And when it comes to like a Android IDE, I can like open up a, what they call, open folder. So, okay, fuck you. Okay. Right. Yeah, so it reconnects by itself, right? So now we can have like a all different kind of code running here and an Android IDE. So now we can simultaneously edit them. Fuck myself, I'm so smart. Right. So we got that setting up done, but we just need to see if it's live or not, right? So we got like Schedulia and it like produces everything we needed to know. Right. So yeah, so they use VS Code plus Endo execution most common. Yeah, generally metadata experience. Arduino CLI. Okay, maybe I should go with Arduino CLI or something, man. Yeah, let's download Arduino CLI. CLI. Like anti-gravity CLI, like do I have IDE? But IDE is like, which one is better? Like, see like, yeah, it's from Google, right? And also there's anti-gravity CLI. Do I need to download that? Because like I think like what is the difference between anti-gravity IDE and CLI? And I do have Arduino IDE. Like I can download CLI too, you know. So what do I do? Download the CLI. Ah, okay. If it's already able to create code, then I don't have to worry. The folder that you have access to right now, like you know, hardware to software and Sketch Julia. Okay, like these folders are directly connected to my Arduino IDE, right? And what I want you to do is like, you know, the like my hardware is connected to Arduino IDE. So you edit the like, you know, folders here, it directly edits the file in the Arduino IDE, right? So that's why I would be using you to actually code software for Arduino IDE, which would be connected to my hardware. Now we need something like a prompt or something. Now what I want you to do is like to update the code. So whenever I connect to my hardware, what it can do is like it can actually take IR commands and can store them into, like, I don't know, its memory or something, whatever the Arduino uses or something. I don't really know that, but yeah, stores it into its memory, right? And then what it does is like each time, like, you know, and then it can store that and send those exact same signals to using my IR transmitter. So it's like there's IR receivers. If I send, like, let's say for example, I send signals from my remote to my IR receiver, right? And those signal appears on this an Android IDE or something. So what I want you to do is like actually decode those signals if you can, and then send those exact same signal to my IR transmitter, right? So yeah, it's like each time, like, yeah, so I can choose or select, maybe also create a web page or something where like all of this in stores. Like, yeah, what I also want you to do is like store the dt by dt. So in like, you know, what that means is like I want you to like the change in temperature, right? If it responds to time, that's what I want you to calculate every, let's say, couple of minutes, and how temperature is like increasing or decreasing over time. Like, you know, and also what I want you to find out is like a relation between temperature and like change in temperature and humidity, right? Yeah, do that and create a web page. I think ESP32 supports that too in its code or something, like a local web page or something. Yeah, do that. Now we just need to send that to ChatGPT to upgrade or something by saying improve this shit. Perfect. Finally, man, finally. We are on the software part. Let's just see if our IR transmitter works. When that works, we can get like a final board and connect everything together. Like, I don't know, but yeah. But I think I do not need to upgrade this. Like, yeah, even though it looks ugly, which it kind of does. Like, it really looks ugly for some reason. But, yeah. So now it's going to generate some code. And once that code is done, I mean, like, yeah. I mean, I did the meditation in the morning, right? That leaves my day. Yeah, I've ticked that. I've already streamed code, but I already need to do reading too, I suppose. Yeah, I was like, yeah, let's just do it tomorrow. Yeah, today I only slept for a lot less, you know. Now I will work on it for some time, right? It will work on it by itself, so I don't actually have to pay much attention to like in its working or something. I can just wait now. Yeah, it's time to wait, so it's gonna create like in a couple of minutes. If your thinking is garbage, AI generate infinite garbage. If your thinking is really great, then yeah, AI generate infinite greatness or something. No, do you guys saw this like the rate of change or something man, at the end? Man, they kind of look like a super intelligence or something, except all. Wait, what? Okay, I can connect it to. I don't know, but yeah, it does Android IDE response. Oh, it does response, man. It does response all the thing. It's done. Self-triggering. Physically close. And enter infinite loop. Ah, this is like, oh, really good logic here. Series of model. Oh, temperature, humidity, linear regression, DT. Generate a file that explains what the software does and like everything about it. Like, yeah, like a simple explanation of everything that I need to know. call that file explanation.txt or explanation.md. You can use anything, like, yeah, you can create a txt file or an md file, I don't care. But yeah, make a better one that explains everything efficiently. Real-time environment analysis learns inferred commands from exec. No, I just need to upload this to my Arduino IDE or something. Like, yeah, let's just use USB 3 because we can. Like, yeah, and let me just do something that anyone with a USB 3 and with some intelligence would do. I guess they won't, but I would. But you get the gist, right? Let me just upload all that. Ah, board is not selected. Okay. How about I disconnect it from here and put it here? Ah, do I still need to select the board by myself? Ha, that's another. It's loading up, right? Yeah, it's loading up. Right, so it should work, I suppose. To some degree, man. I don't know, like, yeah. Let's just hope it works. Oh, I need to go to gym. Oh, it's time to go to gym, guys. It's time to go to gym. I think we would do this like when I come back or something. Compiling, so I think, yeah, it's a big one, but yeah. I think I should stop now and maybe we should do it tomorrow, maybe the after tomorrow right now. We'll return to this. Like, yeah. Man, I'm feel so tired. I could have studied more. I could have done a better performance at gym today too if I slept well. I only slept for like 4 hours or something, and even then on that, like, yeah, it was a really bad time. Compiling sketch. It should be. It's showing it's compiling sketch, but I don't think so. It's compiling sketch. Because like what they have device manager. You should know the COM or something. Here we have my human pods. Yep. Silicon Lab COM9, right? It's COM9. So dev module. Well, edit. Okay. This is great. Okay, now I think finally another big bottleneck that should have been there since the start. Okay, fuck, what did I just minimized it. Yeah, it is there. I think it'll take some time. I just get stuck after this for some reason, man. It just gets stuck. So this is how my table is looking, huh? Looks pretty dirty right now. Okay, it's not working. We did stream code today, so that's like a good achievement. But yeah, I think I'm gonna quit for today now. I think I've done pretty good enough work, I suppose. Like, yeah, I could have done more, but yeah. Let's just minimize that. I'm gonna stop coding right now for now, like as of now. Well, this is heated up, isn't it? But the compiling sketch is not working for some reason. Ah man, I'll do it just after I come from the gym. But yeah, guys. Okay, that's not the angle I want at all. Alright, so yeah, so like this is all for today that we have, right? So let's meet tomorrow or later. Yeah, bye bye.